f from interval 1 to infinity to 2 to infinity. Here 1 is included in the domain side and 2 is included in the range side. Be a differentiable function if 10 into integration of 1 to x ft dt is equal to 5x into fx minus x raised to the power 5 minus 9 for all x greater or equal to 1, then the value of f3 is 18, 32, 22, 26. Okay, let us see. Your function is from 1 to infinity to 2 to infinity. So 1 is included over here and 2 is included in the range side. Okay, we will utilize this concept of interval also if needed. Now our function is of this format. This 10 into integration of 1 to x ft dt equal to 5x into fx minus x to the power 5 minus 9 for all x greater or equal to 1. This is equation 1. Now actually we want to find f3. For that we have to find fx. Okay, so fx is there, but here if we integrate this, then only we get function in the form of x. Okay, otherwise we use Newton-Leibniz formula, which says that differentiation of integral of ft dt from lower limit to ux and upper limit to vx will be equal to function of vx, means function of the upper limit, into differentiation of the upper limit, okay, minus function of the ux, that means lower limit, function of the lower limit, into differentiation of the lower limit. Okay, so actually it is like this: put the upper limit in the function and differentiate the upper limit, minus put the lower limit in the function and differentiate the lower limit. Okay, so we will use this Newton-Leibniz formula to solve this equation 1. Okay, this part. So see how we will do. For that we will differentiate this equation 1. So differentiating above equation with respect to x, we get 10 is the constant, so no problem, 10 is outside of the everything. Now what the Newton-Leibniz formula says, that if you have the case of dy dx of integral of some function with upper limit and lower limit, then what do? We put the upper limit in the function. So fx directly, ft was there, so fx directly, and then differentiate the upper limit. So our upper limit is x, so dy dx of x, plus next time put the lower limit in the function. So our lower limit is what? 1. So f1, and differentiate the lower limit. So d by dx of 1, which will give you 0. Okay, and here there is no problem. Here product rule use 5 into fx, because x differentiation is 1, plus 5 into x, next time f dash x, and this will give you minus 5 x raised to the power 4 minus 0. Okay, so when we solve, you see that 5 and 5 is there. Here this is 0, so it is not needed. Okay, so we can take 5 common. Then after taking 5 common from all these terms, it will be cancelled out with this by 2 times. So twice of fx, because this is 1, fx into 1 plus f1 into 0, this is 0, and this will give you fx plus x f dash x minus x4. Okay. So next time 2 into fx plus x f dash x minus x power 4. This term is 0. When you will solve this, twice of fx minus fx will give you fx, and x f dash x minus x power 4. So in the next time, what we will do, x f dash x will be kept here, minus fx, and this x4 minus sign will go to the left hand side. So finally your equation will be of this format: x f dash x minus fx equal to x power 4. When we divide by x throughout, we will get f dash x minus 1 upon x fx equal to x power 3. Now this is the form, again a differential equation of this format. Okay, dy dx plus py equal to q, where p and q are function of x. In this case, what we will do, integrating factor we find e raised to the power integral of p dx. Here p is minus 1 by x, and then finally integration, what you will get, y into integral factor equal to q into integral factor into dx. So we will apply here in this differential equation. So if integrating factor is e raised to the power, this is your minus 1 by x dxp equal to e raised to the power minus log x, because 1 by x integration is log x. So e raised to the power log x to the power minus 1, because whatever there is in multiplication it will raise to the power of the log. Okay. And e and log will get cancelled. You will get with x to the power minus 1, x to the power minus 1, which in turns will return as 1 upon x. Okay. So your integration of this function can be written as like this: y into if means fx into 1 by x equal to q into if. Q means x cube into if is your 1 by x dx. So this will cancelled, x square you will get, so x square dx, which on integration x power 3 upon 3 plus c. Okay. Now when you will multiply, you can see this x is in the denominator, so cross multiply, so fx will be x power 4 upon 3 plus cx. Okay, this is equation 2. Now we have to find the c, then only we get the fx. So to find c, we put x equal to 1 in the given equation 1. Given equation 1 means in the question, the given expression, it was that 10 into integral of ft dt from 1 to x equal to 5x into fx minus x raised to the 5 minus 9. Okay, here we put x equal to 1 because our interval is given x is greater equal to 1 and up to infinity. So we can put x equal to 1 over here. Okay, to get the c. And one more help you will get by putting x equal to 1 is that whenever you put the limit 1 and 1 means same limit, upper limit and lower limit, then the integral value will be 0. That fact will be used over here. So integration from 1 to 1 ft dt will be 0. Okay, so next time 10 into 0 equal to 5 into 1 f into 1 minus 1 raised to the power 5 minus 9. This I have written here. Okay, therefore 5 into f1 minus 10 equal to 0, because this is 0, 10 into 0. In this way you are getting f1 as 10 upon 5 equal to 2. So f1 is clear. Now you know fx, so we will use this fact now, that value when x is 1, f1 is 2. So f1 1 to the power 4 upon 3 plus c into 1. Okay, so in this way you are getting f1 is 2, this is 1 by 3 plus c is 2 minus 1 by 3, 3 to the 6 minus 1, 5 by 3, c is 5 by 3. So your fx is now fx equal to x power 4 upon 3 plus 5 upon 3 into x. Therefore f3 will be 3 raised to the power 4 upon 3 plus 5 upon 3 into 3. 3 cancelled, this will cancel, and 3 times 3 you will get, so 27 plus 5 equal to 32. So answer option B is correct. Thank you.